Alright, so your CNC material is in there, but what it boils down to is this. Let's say this is the part you want to have a plasma cut system work it out. Maybe you're using wood and you want to mill it out. What you need is a line drawing. So let's say, for example, we're going to use this drawing. So I've drawn it up in AutoCAD here. And there's nothing special about it. All the software, the CNC software is going to do is look at these lines, and it's going to follow the path and cut. So when this part drops out, we're going to have rectangular holes in it and this outline. Make sense? Now it's pretty straightforward. The only difference is with the CNC system, when you draw stuff, there are certain rules you have to give it. You have to give it rules like it doesn't like to see this. It doesn't like to see disconnected lines. It likes to see one nice continuous line. So what tool do we know that we can draw with that gives us one nice continuous line? Polyline. So I can, for a simple part like this, I can simply click on Polyline and trace around my original drawing. And I don't have a bit of problem turning or creating another outline over my original creation. So I click on it now, one time. But here's the catch. Watch this. There are other lines. The original lines are still underneath, right? Here's the problem. CNCs don't like to deal with that. They can't figure out what's going on if there's lines on top of each other. So what I'll do is I'll do a one-click selection of this, this, and this, and I will move them off of the original drawing. Now the rectangle is already a rectangle. See how it's all selected? So it's good to go. This thing's good to go. And now I have gotten rid of the underside lines. In fact, if I do a blue box selection from left to right, see how it's not catching anything? That means that this outline is one continuous shape. Easy to do, and it's easy to forget though. Okay? Just got to remember, the CNC can't handle disconnected lines. Just doesn't like it for its coding process. But that's pretty much the drawing. Once you're done with that, there's another little trick too. There's another command called a boundary that will automatically convert polylines. You can activate it by typing BO and hitting enter, say pick points, and it basically traces the whole thing for you. It did the exact same thing that I essentially just did. It just traced it faster. Okay, so B and O and hit enter creates a polyline for you. Very handy tool. But what do you think? I've got all these drawings on here. Can I just send this file to a CNC software and let it go to town? What's going to happen? Yeah, it's going to go all kinds of crazy because there's too much stuff on here and there's stuff that I don't want. And you can't go in there after the fact and delete stuff out. So what you have to do is typically, after you have your design, you may decide to go create a brand new file. Doesn't really matter what you choose. I'll just choose this one right here, it's my template. And I'm going to copy my design here into that file. How do I do that, by the way? How do I copy a drawing from one file to the other? Any ideas? Yeah, same thing like everything else. Copy paste. So I'll select the whole thing. I can hit Control C or right click and say copy, but not the copy selection, the copy clipboard option. Alright, or Control C again. You do that, you go to your other file, you right click and you say paste, clipboard paste, or Control V, and there's your object. So far, pretty straightforward. The only other problem is this. CNCs are based on numeric coordinates. So you see my XY right there? Does anybody know what the term is for the point 0, 0? Origin, exactly. So I need to get my part somewhere within the proximity of the origin because that's where it's going to start aligning itself. A quick way to do that is this. You can actually move objects by their coordinates. So you can hit your move tool, you can select this, you can hit enter, and you can click on some point of the part and then type in 0, 0. Why would I type in 0, 0? What's that represent? The origin, right? It's the origin of the original thing. So I hit enter and it moves it there for me. But look at it. Do you think I can cut this part? The origin, this part's sticking outside the origin, so I'm going to move this thing over to about half an inch or so inside that direction, half an inch or so inside that direction. Gives me plenty of clearance for my part to be cut out of some other material if you put your edges right on the edge of the origin, then it's likely to burn out or mill out or whatever the case may be. All right, so the object's placed. The last thing I have to do is kind of zoom back, make sure there's nothing else on my drawing, make sure that my layer is 0 layer, because that makes it easy. If you have a lot of layers, sometimes the CNC misinterprets what the layers are doing. So I like to keep it all on 0 layer. And the last thing I have to do is save it in a format that CNC likes to see. Anybody know what that one is? A file format that is universal for CNCs pretty much. Starts with a D, ends with an F. Now, it's close to DWG, but it's slightly different. It's called the DXF. You always got to remember that. Let me just...
So you don't have to change those to a code file or anything like that?
No, what's going to happen is this DXF that I'm about to send out will go to their coder, and it'll make the toolpath off my file. It'll basically import my file in, and then lay out the code.
If you use the stuff for Haas, you got to correct your own G code.
Yeah, and we...
Get after the Haas machines. I was just wondering if you had to do the same thing for the...
Well, on our side of it, at this point, we're not dealing with the code side. We're just saying this is the cut file, or this is the shape we need cut, and then it gets imported into whatever software is used to actually write the code. Does that make sense? So this is where you get the stuff. Now, don't get me wrong. For example, plasma cutting mills, a lot of them, especially if it's 2D, they can knock this out in no time. It's easy. As long as you help them out by placing it close to the origin, but not too close, and accounting is to make sure that you're not past the origin in either of these directions. But here's my trick. All I've got to do to finish this out is do a save as, but I'm real specific on, of course, where I save it to, what I name it, obviously. But right down here is your key thing, your file type. See how it's set to DWG? I don't want DWG, I want DXF, and typically, to make sure that this thing is no complications, I will set it to an old version of like 2000, 2004 DXF. Because these files are very simple, there's no reason to have a higher end version of them. So I'll just say AutoCAD DXF 2000 here, and I'll name the file, we'll call it Eric's Test CNC, and hit save. It may show up slightly different on your desktop screen than most drawing files. You can see it right here. So it shows up as generic DXF, but that's what you load into your slicer or your software to actually write the code. And if you've got everything right, it'll run really easily. Especially if you make sure that your lines are polylined and you are in proximity to the origin. I've seen a lot of people do this right here. They'll get everything looking good, they've got polylines and everything, but what they'll do is they'll forget to place it next to the origin. And so when that CNC machine starts up, it expects a giant piece of material to be sitting on this plate, and it needs to go way over here to cut this part. You don't want that. Another little feature too, a lot of times we like to do batch cutting. We don't want to just fire this thing up for one if we can actually fire it up for many. So your objective in that case would be to copy this part as many times, almost like a cookie cutter scenario, as many times around as you possibly can to facilitate ease of cutting and minimize waste. Why do we want to minimize waste? Because somebody's got to pay for it. Scrap is great and all for the recycling center, but it is costly for those who have to pay for it. So you would need to be aware of what size, what kind of gap you need to leave in your parts. So a little rule of thumb for us is we typically like to leave about 1/4 of an inch between cut distances. We don't put these things right next to each other because that just it'll flame out for plasma cutters. So 1/4 of an inch, but that's not always the case. I mean, different machines work differently, but that's a good rule of thumb for us. So we would go through and lay this thing out based on whatever someone told us they had plate-wise, and try to get as many parts out of it as we can. So there's a little bit of freehand and rotation to make it work better. And then I would do my save as again. I don't want to hit export, I want to hit save as. And I'm going to switch it to DXF, name it again. I'll call it Eric's Test CNC2, hit save, and there it goes. One little thing that AutoCAD will do when you get done with all this is when you hit save to end your file, it's going to say, do you want to save it as DWG? That's fine. Just realize that the only thing you can send to the CNCs are typically DXFs, and they're going to look slightly different. Now, here's a question. I'm looking at these 3 files on my desktop screen right here. Other than the fact that this one says CNC or DXF on it, how could I know that it's a DXF without a question? What could I do? What computer trick can I do to figure out what type of files they are? Right click. Yeah, absolutely. Left click to select, right click, and hit Properties. It'll tell you what type it is. This one's a picture image. This one, right click Properties, is a DXF file. That's how you can always confirm what type of files you're doing before you send it to somebody, because there's nothing more annoying for someone to get out there on the floor, get the equipment all set up, and realize you sent them the wrong file type. So watch out for those kind of things. Questions? CNC applications, automation like this, super great. I mean, just saves such a huge amount of time and can do some crazy impressive cuts. In fact, it allows you to lay in your drill holes and everything. You can either lay in holes that are sized for actual final use. For example, 0.5 would give us a 1/2 inch diameter hole. Or you can do pierce points by making a small little hole, let's say a diameter of 0.125. We'll give you an 1/8 inch hole to make a pierce point, and you can use that as a pilot hole for your drill. But just can't underestimate the power of these things and adding fillets and all kinds of stuff into it. So great stuff. Questions? All right, let's get back to it.